and welcome to another video. To prove that A sine 1/2 of B minus C is equals to B minus C cos 1/2 of A, okay, we need to first establish that the left hand side is equivalent to the right hand side. Now the question says in triangle ABC, prove that the left hand side is equivalent to the right hand side. Now this is one of the topics in advanced trigonometry known as solution to triangles. So any question that we're given that in triangle ABC, okay, and we want to prove that the left hand side is equivalent to the right hand side. So this is a question under what we call solution to triangles, and it's one of the topics in advanced trigonometry. All right, so now let me use the right hand side to prove the identity on the left hand side. So first I'll write that the left hand side is equivalent to the right hand side. Now, the right hand side is equivalent to B minus C cos 1/2 of A. Now, in this case, I'll need to first write an expression for B in terms of sin B and sin A. And I'll also write an expression for C in terms of sin C and sin A. That is, I'm going to apply the sine rule, okay? Applying the sine rule, okay, applying the sine rule, we know that sine rule states A over sin A equals B over sin B, and this will be equals to C over sin C. Now to write the expression for B in terms of sin A and sin B, I'm going to what? I'm going to bring out A over sin A equals to B over sin B, okay? Then from here, I can make B the subject of the formula. So making B the subject of the formula, this will be A sin B over sin A. So this is the expression for B in terms of sin A and sin B. Then I will again write the expression for C in terms of sin A and sin C, using this by equating A over sin A and C over sin C. So that will be when we equate A over sin A with C over sin C. So the expression for C in terms of sin A and sin C will be, this will be C equals to A sin C over sin A. Now we can substitute this for B and also this for C in this expression. All right, so from what we have as the right hand side, we have B minus C cos 1/2 of A. So this will be, for B we have A sin B over sin A, minus for C we have A sin C over sin A, then multiply by cos 1/2 of A, cos 1/2 of A. Now A is common, okay, in this case, so I'm going to factor out A. So we have A into sin B over sin A, minus, now because we have A as a denominator for both, okay, so this will be a common denominator. So sin A is a common denominator, so we have sin B minus sin C, then multiply by cos 1/2 of A. Okay, now let's recall the identity for sin B minus sin C, okay, using one of the sum to product property, okay, sum to product property. So now let's recall. Now you recall that if we have sin P minus sin Q, this will be equals to 2 cos P plus Q over 2, okay, then sine P minus Q over 2. Yeah, this is one of the sum to product identities. All right, so which means for sine B minus sine C, we're going to have this to be equals to 2 cos B plus C over 2 sine B minus C over 2. Okay, then also let's write the half angle formula for sine A. Now also we know that sine A will be 2 sine A over 2 cos A over 2. Now, what is now the relationship between angle A, B, and C? So now I can draw triangle ABC for us to see. So we have triangle ABC, ABC. Opposite angle C will be side C. Opposite B will be lowercase letter b, which is side AC. Opposite A is side BC, which will be represented with lowercase letter a. All right, now we know that by using angle sum property of triangle, that is using the angle sum property, that is the angle sum property of triangle, we're going to have angle A plus angle B plus angle C to be equals to 180 degrees. Okay, now I can write angle A to be equals to 180, okay, minus parentheses angle B plus angle C. Okay, so which means that sine A will be equals to sine 180, okay, 180 minus parentheses angle B plus angle C. And when we have sine square bracket 180 minus the sum of angle B and angle C, okay, this will be equals to sine B plus C, okay, to be equals to sine B plus C. So which means sine A, okay, will be B plus, will be equals to sine B plus C. So which means that sine A will now be equals to 2 sine B plus C over 2 using the half angle formula for sine A. Then cos multiplied by cos B plus C over 2. Okay, so now we can now substitute this, okay, back into what? Into this expression, and also substitute this for sine B minus sine C, okay, into this expression. So we have that from A sine, okay, from A open parenthesis sine B minus sine C divided by sine A, okay, divided by sine A multiplied by cos 1/2 of A, okay. So we're going to have this to be equals to A, okay, let me use a square bracket, okay, square bracket 2 cos B plus C over 2, okay, sine B plus C over 2, all over, then for sine A, okay, let's not forget that this is what we got for sine A, okay, and this is what we got for sine B minus sine C. Okay, so this is for sine B minus sine C. Then for sine A, we have 2 sine B plus C over 2, okay, then cos B plus C over 2. Close the bracket, then cos 1/2 of A. So in this case, this will cancel this, 2 will cancel what? 2. Then we'll be left with, so in this case we have Oh no, this is sin B minus A. Okay, my sin B minus C. We have sin B minus C. So this cancel this, this cancel this, this cancel this, this cancel this. Okay, so we'll be left with A sin B minus C over 2, okay, over sin B plus C over 2, okay, multiply by cos½ of A. Now, in this case, we know that if we have sin B plus C to be equals to sin A, okay, so which means that sin B plus C, okay, now let me write this. Recall, sin B plus C equals to sin A. So which means that sin B plus C will be equals to sin 180 minus A. Okay, sin 180 minus A. So now, which means if we now have sin B plus C over 2, this will be sin 180 minus A over 2. Okay, so which means sin B plus C over 2, sin B plus C over 2, sin B plus C over 2 will be sin 180 over 2 minus A over 2. Okay, so in this case, this will be sin 90 degrees, okay, because 180 divided by 2 is 90, then minus A over 2. Okay, so now, using the fact that sin 90 minus A is equals to cos½ of A, okay, that is the first quadrant. So then we have A sin B plus C, B minus C, okay, B minus C over 2 divided by, so we now have sin B plus C over 2 to be equals to cos½ of A. Then let's not forget that we have the numerator multiply by cos½ of A, so that this will cancel this. Then we now have A sin 1/2 of B minus C, and this is equals to the left hand side. Okay, this is equals to the left hand side. So therefore, the left hand side, okay, is equivalent to the right hand side. And we just show that the right hand side, I just show that the right hand side can be used to derive the identity on the left hand side. With that, we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.